Okay, class, we are on to chapter 8, which is all about exponents. And exponents are something that scientists use a lot, and to measure distances and write them in a simplified form. So we are going to start with the different properties. So the first one we're going to do is the product of power properties. So up here we have an example. A is the base. So I want to start with going through everything. A would be the base, and 2 here would be the exponent. So it's important that you understand. And then we have a to the second power times a to the third power. So 2 and 3 are what the powers would be. So if we are going to start with the first rule, the power property means that you add. So if I have 2 and 3, the bases have to be the same. So I add them together and I get a to the 5th. All right? So we're going to start some examples from this. So 8.1, applying exponent properties involving the product property. So 7 to the 5th times 7 to the 3rd. So again, the bases are both 7 and the powers are different. One is a 5, one is a 3. So according to these rules, because they have the same base, I can just go ahead and add the powers. 5 plus 3, which will give me 7 to the 12th power. All right, here, 9 times 9 to the 8th times 9 to the second power. Again, all the bases are 9s. So when you have nothing written, understand that it means there's a 1. So if I'm going to add these together, the multiplication, so this is a power property, means that I can add 1 plus 8 plus 2. So I'm just showing you this to start out. As you get more advanced, you're not going to need to write this out. You understand you're just adding. So that's going to be 9 to the 11th power. Okay. So now, say we have a base of -5. Whenever it's anything more than just a 5, has a negative, or you can have bases that are a lot bigger as we go on, they put a parentheses around. So say you saw this, parentheses, base of -5 times, and sometimes you'll see the multiplication, and sometimes if it's in parentheses, you can tell that that means multiplication. So this is to the first power, so if I added them together, I would have the base of -5 to the 7th, and you always put parentheses around it if it has more than one thing. So here, when it's just a 9 or a 7, you don't need parentheses. Again here, so if I had x to the 5th times x to the 4th times x to the 10th times x, I'm just making it up as I go. These all have the same basis of x. So that means this is the multiplication. That's why you don't have a parentheses around. You just add 5 plus 4 is 9, plus 10 is 19, plus 3 is x to the what? 22nd power. So that's how we do it. They can be as big or as small as you want. Alright, so I'm just going to put this up. I think you understand that you're just adding them together. So I'm going to put this up and show you the powers of a power. So here it means a to the second is a power times to the third. So you're raising one power 2 to another power to the third. So when you do that, you are multiplying, okay? So you have to remember, power of a power property means you multiply. So you want to write that down, because keeping these powers straight is what you need to be able to do. So So let's start with a few examples here. So remember, your foundation, 8.1, is always the easiest, but it's also the most important because it lays down the whole foundation for everything that the sections are built upon to end this chapter. So here we go. 2 to the 5th power, that's raised to 1 power, and then raised to another. That's why it's called product. Use the power of a power property. So, power of a power property. Okay, so here it means multiply. 5 times 3, so I'd get 2 to the 15th. So you multiply when you have a power of a power. So here, parentheses, -6. Okay, and this is going to be to this. Actually, let me write this a little better. Squeeze together. Let me write this a little clearer. Okay, I've got a base of -6 raised to the 2nd power, and then the whole thing is raised to the 5th power. So that means we just multiply 2 times 5, and now because we've done that, we can just put the parentheses around that. Remember, if you have more than one thing, you have to put parentheses. Your whole base is -6, okay? Raised to the 10th power, 2 times 5. Okay, here, x to the 2nd, raised to the 4th, that becomes x to the 8th. Just multiply 2 times 4. So here, look, you can have a base as big or as small as you want. So the base inside is y plus 2 raised to the 6th power, and then you have the parentheses to show that's on the outside, so a power raised to a power. But the base is y plus 2. So it can be as big as small as you want. Y plus 2 raised 6 times 2 is 12, and that would be correct. Okay, so that is taking a power and raising it to a power. Okay, so now we're going to get where we have more than one base. So say we have a, b raised to the 4th power. What that means, if I break it down, this is a 1, you understand. There's always a 1, we just don't write it. It's the same as saying 1 times 4, so a to the 4th, then b, 1 times 4. They're two separate things, but in the same base. So you've got an a and a b. Alright, I could have numbers. I could have 5, that's a base, times 6, and they're raised to the 7th power. So I'd write that 5 to the 7th, and then times 6 to the 7th. Alright, so let's practice a few examples of this where we have different bases. And the reason you put multiplication between the numbers, so you don't think of it as 30. If it's a and b, you don't have to put a multiplication number in between because you can clearly see that they're different, okay? So here, 24 times 13 raised to the 8th power. And because they're numbers, that's why you go ahead and write 24, base of 24 to the 8th, times 13 to the 8th. Okay, but you can see when it's not numbers that it is easy to tell. Okay, so I've got a base of 3 different things, a number, an x, and a y. So a base of 9, a base of x, and a base of y. So you take this, and a way of rewriting it is saying 9 times x times y, all to the 2nd power. So I'm expanding it right now because I want you to understand what you're doing. 9 to the 2nd power, that's a number that can be simplified. Okay, so 9 squared is one way to look at it here. X squared and y squared. Now, if you can simplify a number and it's not some huge number, then you simplify it. That's one of the rules of exponents. Now, x and y, that's different. But if it's a number like 5 squared or 9 squared is 81. Remember, it's 9 times 9. X squared and y squared, and that is it, simplified down to its smallest form. So let's go ahead and try one. Here, I've got a base of negative 4z raised to the second power. So I want you to think that negative 4 is one thing, so it's best to write it out until you get more proficient at it. That's negative 4 raised to the second power, and then z raised to the second power. Negative 4 raised to the second power means negative 4 times negative 4. And if you multiply, remember, if you put this in your calculator, put parentheses around it. That means negative 4 times negative 4, that's going to be positive 16. Okay, a negative times a negative is always a positive. And then z to the second power, and that is your final answer. Okay, so I want you to look at this, and so here's this, but look at the difference. Okay, if I have this, I've got a negative outside, and I've got 4z to the second power. Look at the different answers that you would get. Here, you're squaring negative 4. You're raising that to the second power. Here, the negative's on the outside. So you keep the negative on the outside, and you say 4 to the second power, because that's in the base inside the parentheses, and z to the second power. The negative isn't affected. That was not squared at all. So the negative stays on the outside. 4 squared is 16. Z squared is z squared. So do you see the difference between here, where you square a negative 4, so you're saying negative 4 times negative 4, giving you a positive 16, and here, where the negative's on the outside, it is not squared at all, and all you do is square 4, which gives you a positive 16, but then the negative is assigned because it's on the outside still. Alright, so understand the difference between those two things. So now we're going to use all three properties that we've learned. Addition, power property, and the power of a power. So here, I've got 2x cubed raised to the second power times x to the fourth. Actually, let me pull that down. So the rule is, if you have anything in parentheses, you always have to simplify it first. So you do that first. So this is, like I said, an invisible 1 there. So 2 squared is going to be 4. And then here, this is a power to a power. So we did that same here. We said 1 times 2 is 2, and 2 to the second power is just 4. It can be simplified. X is 3. 3 times 2 is 6 times, I'm doing it slowly because you're just learning it, so you do it step by step. Now this was the first power that we used, where you multiply these bases, they're the same, x and x, that means you add. So 4 is not affected. X, I've got 6 plus, let me show it out, 6 plus 4. So the final answer to this is 4x to the 10th power. Okay, so look at how it's broken down. I'm going to do a couple more. Okay, so here's, so you can see a couple of examples. 9m cubed n all raised to the 4th power. Okay, so that means we have a 1 on all of these. So let me write it out. That's 9 to the 4th, m cubed raised to the 4th, and n raised to the 4th. Because this is just 1 times 4. The reason I put this in parentheses because I'm showing that this has a cube and it's raised to the 4th power. So 9 to the 4th, 9 squared is 81, and 81 times 81, I forgot to bring my calculator, 1 times 1 is 1, 1 times 8 is 8, 0, 8 times 1 is 8, 8 times 8 is 64. So that's going to be 1 16, 5, 6,561. So I don't know if I'm supposed to, that's kind of bigger number. M is 3 times 4m to the 12th or n to the 4th. Either way, on a test, because test is always paper, I will take 9 to the 4th, m 12, and n to the 4th. You kind of simplify it when it's kind of smaller numbers, but whether you simplify it when you calculate and say 9 to the 4th and do it like this, or leave it like that because it's a fairly big number, I accept both. But if it's something like 5 squared or 5 cubed, and it's less than 1,000 or 2,000, then we pretty much simplify it. Alright, let me try another one. Let's look at something again. Let's have another little challenging one here, because the more you see it, then you'll know exactly what to do. Okay, here's a nice one I found. Alright, so here we go. 3x to the 5th raised to the 3rd power times 2x to the 7th raised to the 2nd power. Okay, so you've got a power of a power for the first one, a power of a power for the second one. So the first thing you have to do is get rid of the parentheses. It's just like with PEMDAS, you distribute, get rid of the parentheses first. So that's considered a 1. 1 times 3, that's 3 to the 3rd power. I'm going to write everything out. This is 5 times 3, that's x to the 15th. Alright, so I've simplified this. Now I'm going to go ahead, and there is a multiplication, so I'm going to leave a gap here. This is 2 to the 2nd power, which is actually, let me go ahead and write everything out just like I did. 2 to the 2nd power, because 1 times 2, and that's x. 7 times 2 is 14. Okay, so you can put a big parenthesis, multiplication symbol in between there if you want. That'll help you to remember. Now simplify. 3 to the 3rd power is 3 times 3 times 3, that's 27. X to the 15 times 2 to the 2nd power is 4, and x to the 14. So look how I simplified that. And now 27 to the 4th. So these are just regular numbers, so you multiply, alright? So you'd go on your calculator, 27 times 4 is 108. Okay, and here, these are bases of x, so you just add them. See how they're the same? 27, 4, just numbers, are not the same bases here. So 15 plus 14 is x to the, 29th? And there you go, you've simplified it. One bit at a time. It takes practice, okay? Alright, real quick, I just want to throw up a real easy word problem. I'll just use it from here. Okay, solve a word problem. Okay, in 2003, the U.S. Department of Agriculture collected data on about 10 to the 3rd honeybee colonies. So you'll see in science, when they deal with like really large objects or really small objects, instead of writing like, you know, all these zeros, these huge numbers, they found a way to write it. So you take a base of 10 to the 3rd power, which is really 1,000, but as the numbers get larger and larger, and the trillions and billions and on and quadrillion, you don't want to write all those zeros. And especially if you're multiplying one by the other, can you imagine having a page full of zeros? So they take this shortcut, so 10 to the 3rd. Then there are about 10 to the 4th, which would be 10,000 bees in an average colony during honey production season. But how many bees were in the USDA study? So to find the total number of bees, you find the product of the number of colonies. You have 10 to the 3rd, and the number of bees per colony are 10 to the 4th. Just multiply them, which means they add them. So this would be just 10 to the 7th power, which is a lot easier to write than all these 7 zeros here. Okay, so we're looking at 10 million bees. Lovely. I like bees. But anyway, they're good for us, right? The honey and the pollination of the flowers. But we are going to move on to 8.2. God bless, guys.